So I think it'd be helpful if to start with, we've sort of written this identity out. So why don't we write out the three cos 2x identities. So that's the one I always remember. So see if you can tell me remember the two variations. There's one where you replace that, and there's one where you replace that, isn't there? And then you've got another two identities that you get that start from sine squared plus cos squared equals 1. There's one where you divide everything by sine squared and one where you divide everything by cos squared. I call those the reciprocal identities. So why don't we just start by writing those out? Try and do that without sort of looking at your ILF trig sheet if you've got it with you. If you haven't, well, you can't. So this is good practice for how we've remembered those identities. So if I replace cos squared with 1 minus sine squared, I get 1 minus sine squared minus another sine squared, so that's 1 minus 2 sine squared. And if you remember these, then kudos to you. And this one is a bit trickier because I'm going to replace sine squared with 1 minus cos squared, but it's minus that, so you get minus 1 and minus minus cos squared, so that's 2 cos squared, so that gives you that. And then if you divide everything here by sine squared, you get 1 plus cot squared x is 1 over sine squared, which is cos x squared. And if you divide everything by cos squared, you get tan squared plus 1 is 1 over cos is sec squared. So, I've just sort of modelled there how I would operate in an exam situation, and I probably wouldn't do all of that until I hit a question where I felt like it was needed, and I think you need to have those spider senses that tell you that, remind you that there is a relationship here, and if you can't remember it, and there is a relationship here, even if you can't remember it. So let's try an integration that uses that. And we have just done the one on the left, although I'm conscious that for those that are watching the video we haven't, so I'm going to write that one up here. But for those of you here, here's something which, well, the first thing I'd do is have a look at my formula sheet, but the squared confuses me, so there's no help initially. So I'm going to multiply that out. And remember, with most differentiation integration, multiplying out brackets generally is a good start. So grid out that bracket for me. for those watching at home, this looks a little bit like this, and I know that that is sine 2x. So if I go from that to this, x has become 3x, and I've got half as much. So I've actually got half of sine, well, if x has become 3x, 2 lots of that would be 6x. So integrating that is the same as integrating a half. Don't have to put the half outside of the students. Sine becomes minus cos. We've got the half as well. But then you've got to divide by what you get when you differentiate the bracket. So I'm going to divide by 6 as well. So that's going to be
2:30 okay today? What time do you leave?
To be fair, the thing that I needed to look at,
So gridding it out gives me that. So my attention is going to turn to the formula sheet. Sec squared I can integrate because it's on the differentiation table on the right hand side. So that's going to give me tan. Sec x tan x I can also see on that page 6 table on the right hand side. So that's I can integrate. That's going to give me 2 lots of sec. This is a pain. Can't see tan squared on there. But I don't know what, something rings a bell. Tan squared. I can rewrite tan squared as sec squared minus 1. And both of those are things I can integrate. So I can rewrite that using that identity. And that's going to make it all something that I can then integrate. Most of which I'm using the formula sheet for, although I've got to remember what I get when I integrate 1.
Swing by half this at some point today, grab a memory stick, grab a memory stick, I'll put all my files onto memory stick, and one of the memory sticks, one of the files, look, is everything minus that, which is the vast majority, might be like 60 to 70 kids. That's the one we use, and then the 6 orders, there's only 12. At least you'll have a spreadsheet on Mike's done, and he says like if they've done dash, C, exclusive, whatever it is, then you'll know the name, and it's then working out from that. I'll use that across what formats I've done, and then the year I've done. Yeah. I'll just show you what I've got so far, and then you can work on it.
Cool. I did.
I was doing one day.
So 2 sec squared x is going to become 2 tan x. I just rolled those 2 secs together, sec squareds together. Sec x tan x would be sec x, so that's 2 lots of that. And when you integrate 1, you get x. So that's our answer to that. And we're straight back, aren't we, into those identities, and just like the proof and solve questions, there's no way that I can show you every possible type of question that can come up. The only thing we can do is sort of commit to practice. And so let's do a little bit of that now. Page 300 in the books I've given out. Question 2 and question 6. Question 2 is in several parts. I have a feeling it's one where I'll say just do a column. Well, I'll tell you what. Let's do the first. Let's do the first two columns. Otherwise, we won't get anywhere with that. And can I help you with the first one? We've got two things divided by one thing. So we've already seen where brackets, we can multiply those out, and that often helps. Of course, if it's a simple linear expression in the bracket, we can integrate it. We did that the other day, but here we've got something very complicated. But two things over one thing, I can split that into two separate things. So what I get is 1 over cos squared minus sine over cos squared. I can't do that with one thing over two things, but with two things over one thing, which is going to crop up 3 times in this, although actually that will be 3 things when you've multiplied it out, I can split that up. Now, still haven't got something I can integrate yet, but 1 over cos is sec squared. Bingo, page 6. And we came across this the other day. Do you remember I said write it as sine x times 1 over cos x times cos x? So that gives you sine over cos, which is tan, and 1 over cos, which is sec. And I said I can't go through every possible thing that can crop up, but that's cropped up twice in 2 lessons, so that's a good one to remember. Sine over cos squared, you can turn into sine over cos cos, and sine over cos is tan, and 1 over cos is sec. And that is something I can integrate. All of that I can integrate using the formula sheet. Okay, so if we just do the first 2 columns, so that's 6 examples there. And don't forget those identities that we wrote down earlier. So again, two things over one thing, I've split them up. 1 over sine squared is cosec squared on the formula sheet, how to integrate that. And cos over sine squared, very similar to this one. Split it into sine and sine. You've got cos over sine, which is cot, and 1 over sine, which is cosec. And you think, there's no way I'm going to be able to integrate that. It's on the formula sheet. Cot cosec, or cosec cot, is minus cosec. If cosec becomes minus that, then minus cosec would become plus that. Trying to work out you've got a cot squared, and it's not the formula sheet, but cosec squared is on the formula sheet. So although I have to keep that. Oh, yes. Sorry? I propose we do the first two columns, so A, B, D, E, G, H, just because I think I'd like to get into question 6. But if you do it more than that, that's fine. So in all of these, k is 1, isn't it? You know, that's the k's on the formula sheet. I've got both of those right. Yes. Yes. So cot squared, I can't integrate, can't find it on the formula sheet, but it's cosec minus 1. There's a whole lot going on if you're on E, because when you multiply out the top, you get three terms: 1 plus 2 cos x plus cos squared. So you can write it as three separate fractions, three things divided by one thing. 1 over sine squared, we've come across that already, we can integrate it. We've come across this already, we can integrate it. We've come across this already, we can integrate it. So that's quite a nice question in that it sort of pulls in things from the previous parts. Can I just give you one minute to finish the one you're on? I'll show you the answers then. I'd like to have a look at 6, and I'd like to have a look at an extra one of the modification questions. Okay, so I, with E, got as far as that, so that gives you cos x squared, and it gives you cot x cosec x, and it gives you cot squared, and then you need to use the identity that we already used it for, and you should have ended up with minus 2 lots of cot x minus an x minus 2 cosec x. And for G and H, you need to multiply out the brackets. So G, you ended up with a cos squared and a sine squared, which is 1. And you ended up with minus 2 cos x sine x, which is sine 2x. So 1 becomes x, and minus sine becomes cos. So minus sine 2x becomes cos 2x divided by 2. So that's where the half came from there. And with H, if you multiplied out the bracket, you got cos squared, you got 2 cos sec, and you got sec squared. Cos squared we know how to integrate. It's a really complicated process. And sec squared we know how to integrate. And cos x sec x. Oh, that's 2, isn't it? Because you end up with, that's cos and that's 1 over cos, so that just becomes minus 2. So that's a really fiddly one. If you were on that one, then that's quite a long one, but well done if you got somewhere with it. Particularly the integral of cos squared and sine squared are particularly fiddly. I suspect we didn't get on to 6. I might start tomorrow with 6. What I would like to have a look at is, if you did 6, then show the answer. I did it differently to them. I wrote it as 5 sine squared plus 5 cos squared, which is 5, plus 2 cos squared x. And then I did the cos squared x replacement. I think I might start with that one tomorrow then. So can we have a look at this question? I'd like to sort of finish with this question here. So we're trying to integrate here cos to the power of 4x. I guarantee that in some way, shape or another, cos squared or sine squared will feature in an integration question. And it may seem that this isn't initially a cos squared or a sine squared, but if I point out to you that cos to the power of 4 squared, sorry, cos to the power of 4 is cos squared squared. So if I, okay, right, cos to the power of 4 is and because this is an integration question, I know I'm going to have to use this, sorry, not that, this substitution, aren't I? This is the substitution for sine squared, so I've got to use the alternative one for cos squared. So let's go to our list of identities. Here we go. If I pick up with that one, 2 cos squared x is cos 2x plus 1. So cos squared x is a half of that. So let's write that in there. A whole lot of brackets going on there. Now we talked about this yesterday. When I'm squaring a product, two things multiply together, I can just square the two things separately. So I can write that as a half squared, which is a quarter, times cos 2x plus 1 squared. However, if I'm adding or subtracting two things and wanting to square them, I've got to grid that out. So let's grid that out. Now, they're helping me out a little bit here because it's a show that question. So I'm sort of feeling quite happy at the moment because that term there, I know I've already got, because a quarter of 2 cos 2x is a half cos 2x, so that's all good. But I feel like I'm caught in a loop here because I'm trying to get rid of cos squared, so I've replaced it with this. And I've ended up with another cos squared. This time it's cos squared 2x. So let's go back to the identity. Here we go. And this takes us back to what we did at the beginning, really. If we wanted to have cos squared 2x, that would be 4x there, wouldn't it? If that's, so that means we've got 4x there, cos squared 2x. So cos squared 2x is a half of cos 4x plus 1. So I'm sort of caught in a bit of a loop here. I'm hoping I'm going to pop out in a minute. So cos squared of x is this. So cos squared of 2x is going to be that, just replacing the x with 2. Because I haven't done any integrating, I don't need to worry about, sorry, it's not a quarter, it's a half. It's not dividing by anything as well. So I've got a half of cos 4x plus 1. So I've replaced that with that. Let's go back to my show that, and I know this is horrible, which is why I've saved it till the end, but you know, I'm not doing my job if I don't show you the horrible stuff as well as the slightly easier stuff. So have I got what I'm after? So I've got a quarter times a half of cos 4x. Yes. I've got a quarter times a half times 1, which is an eighth, plus, what's going on there? I've got ended up with 9/8. Why have I ended up with 9/8?
Don't you have to do a quarter times 1? And then that's...
Yeah, yes.
And then that's 2/8, and then you add 1/8 to 2/8, and get 3/8.
Yeah. Oh, sorry. Yes. Oh, thank you. Yeah. Of course. Yes. Right. Sorry. Yes. So I've got 1/8 there, and a quarter of 1 is a quarter, and yeah, that's 3/8. Phew. Okay. I've got the 3/8. That's good. And I've got a quarter of that, which I already know is so we're okay. As required. As required. Go on. See if you can now integrate it. So I know how to integrate cos 4x. I know how to integrate cos 2x. I know how to integrate 3/8. Just like integrating 1 becomes x, 3/8 is going to become 3/8 x. So this just is the circle in reverse. So cos 4x becomes sine 4x, but I've got to divide by 4, and I've already got 1/8, which is dividing by 8, so that's dividing by 32, which let's choose to write like that. And cos 2x becomes sine 2x, but I've also got to divide by 2, and I'm already dividing by 2 because I've got a half, so that gives me 1. Now that's the hardest example I can find, so don't think, don't think that's, I'm no good at this because I can't do that easy example. No, that's a really hard example. And the good news is we move on from trig next lesson. Not forever.
It wasn't